Hi, this video is about power and intensity. We have discussed power a little bit before in the circuits unit, and when we talk about power, we're talking about something in watts. Typically, when we think about watts in our day-to-day world, it's light bulbs, but it's also speakers. If you have a really nice speaker, go check and you will see it has a power rating in watts. So power in watts is one piece of what we're going to be talking about with intensity. Now, intensity, you actually know this already. If you stand really close to a campfire, you're really nice and warm. If you stand far away, it's colder. If you stand really close to a bright light, it's very bright. If you stand farther away, it's dimmer. This is the idea of intensity. So intensity, it's defined as the power, but it's also got something to do with distance. And it turns out it's the area. So the power of a source, and now we're saying how much is that power spread out? Is it spread out over a small area? Is it spread out over a large area? And so this should make sense that if it's spread out over a small area, if you're close, it's more intense, it's brighter or warmer. And if it's spread out over a big area, if you're farther away, it's less intense. So with sound, what would the area be? So I have a source of sound here, a speaker or something, and it's sending out sound waves in all directions, right? And is that a one-dimensional, two-dimensional, or three-dimensional wave? Well, does sound go in one direction, two directions, or all directions? All directions. Sound is a 3D wave. So what is the area associated with three-dimensional? What would it be? It would be a sphere. So circle for 2 dimensions, sphere for 3 dimensions. What is the area of a sphere? And now this is a little bit different than what you might be thinking. You might go automatically to volume. We want just the surface area. For a circle, pi r squared. It turns out for a sphere, it's 4 pi r squared, where r is the distance from the source. So if you're standing really close, it's a small area circle. If you're standing far away, big R, it's a big area circle. So the intensity for sound is power over 4 pi r squared, where r is the distance from the source. So let's do an example. If we have a 100 watt bulb, 100 watt light bulb, and we stand, let's see, 1 centimeter away, close, huh? What is the intensity? Okay, intensity is power over 4 pi r squared, so it's going to be 100 watts over 4 pi r, and now be careful, centimeters, we have to convert to meters, 0.01 squared. And I'll get rid of that from the 100 over 4 pi times 0.01 squared. And in your calculator, don't forget, put all of this in parentheses if you're doing it in one step. So 100 over 4 pi 0.01 squared, I get a really big number. Oh my goodness. 79,580. Now what is a unit? Power on top and area on bottom, r squared, meters squared. So intensity is watts per meter squared. So that's 1 centimeter away. That's pretty good intensity there. How about 1 meter away? Well, you know that it needs to be less intense. We're 100 times the distance away, so it's going to be a lot less intense. If we do the math, it would be 100 over 4 pi, let's just do it like that, 1 squared. If you do that math, it's 7.958 watts per meter squared. So 100 times farther away actually is, let's see, 1, 2, 3, 10,000 times smaller, 100 squared. This is the 1 over r squared situation we've dealt with a couple times now. We've had it with Coulomb's law and a couple other places where we've had this 1 over r squared. So if we double the distance away, the intensity doesn't go down by half, it goes down by 1/4. So what kind of numbers do we typically deal with for intensity? I always like to try to give you some numbers so you know if your answer is at all reasonable. And I try to make things come out to be reasonable numbers. You know, for light bulbs, the watts in the 50 to 150 range for the power rating. Intensity does have a lot more spectrum. It's a lot bigger range that we can have the numbers in. Something to just keep in mind, if we have sunlight, so it's a nice sunny day, well, the sun has a certain amount of power, and by the time, we can figure out how far we are from the sun. Sunlight is pretty darn powerful. We actually have about 700 watts per meter squared of sunlight. It's up to 1,000 watts per meter squared of sunlight for the intensity of sunlight. So like peak sun, solar noon at the equator or something, might be up to 1,000, but in general, we're looking at 500 to 1,000 watts per meter squared for sunlight. And so we've got, you could have numbers as small as this, like 8 watts per meter squared. This would be a real quiet sound. You'd be far away from a speaker or far away from a bulb. But again, we can have something pretty big too. So it does have a broad range of units, and you're just going to have to kind of go with your gut on saying, does this seem reasonable? Because we don't have a good just small range, like the coefficient of friction, 0 to 1. If it's between 0 and 1, you have a pretty good guess that it's right. So I don't have much of that for you. What else about power and intensity? I guess that's really about it. So keep in mind, when you see area, don't go to pi r squared, because that's 2 dimensions. That's a circle. We are dealing with 3-dimensional stuff, light and sound, and so we need the area of a sphere, 4 pi r squared. And then remember, put this in parentheses in your calculator. Otherwise, you'll have 100 divided by 4 times pi, and then times 0.01 squared. And don't square the whole thing. It's just that r squared, just squaring the r. I guess that's all I've got for you. So there's a short introduction to power and intensity. Good job.